next section that we want to look at is simplifying expressions involving combining like terms. This is going to cover sections 1.4 through 1.8. In order to be successful in this section, you need to know how to add and subtract integers. Upon completing this presentation, you will be able to identify like terms and simplify expressions using techniques for combining like terms. In order to simplify expressions by combining like terms, the first thing we want to do is identify our like terms. We're going to add or subtract the coefficients of these terms. We're going to keep the same variables, and if those variables have exponents, we keep those the same as well. There's a couple different things you can do in order to help you remember how to do this. One of the things is think of variables as being the units of a term or being objects. For instance, if you have 2 bears and 3 dogs, do you have 5 bear dogs? Hopefully not. Bears, dogs, these are not the same units. They would not be considered like terms and therefore cannot be combined. Another thing to consider is remember when we talked about adding and subtracting fractions. Remember that we could add like fractions by adding or subtracting the numerators, and we kept the same denominator. With fractions, we could rewrite them using the same denominator. Unlike this section where we talk about like terms, we can't turn an x into a y, and so if they do not have like terms, then they cannot be combined. So let's look at the following examples and see what we can do. If we look at example A, we have 4x plus 15x. 4x plus 15x, we want to start by adding the numbers 4 and 15, and we get 19. We keep the x, and you're done. For example B, if we combine our numbers, what is 7 minus 2? We get 5, and we keep the a. So 7a minus 2a is equal to 5a. Now if we look at example 6, or example C, we have 6x plus x. What do you think this would be equal to? One thing to note is that if there is no coefficient in front of the x, it is implied to be a 1x. For instance, you guys see me with sodas in class all the time. I have a soda. I don't say I have one soda. Granted, it's because I usually have more than that. But it's just 1. So if ever you do not have a coefficient, it is implied to be a 1. And now we can do exactly what we did in the previous examples. 6 plus 1 is equal to 7. Keep the variable, and so we get 6x plus x is equal to 7x. Alright, let's look at D, where we start getting some exponents involved. We're still going to do the exact same thing. I still want to add my coefficients. We get 7 plus 2 is 9. I still keep my variable, and I keep my exponent. Just think about if you have 7 blocks plus 2 blocks, you still have 9 blocks. A block is another word for a cube. Alright, so now let's go ahead and move over to some other ones. If we look at example E, we have 5x plus x squared. This is equal to 6x squared. Again, since there is no number in front of the second term, it is implied to be a 1. So we add 5 plus 1 to get 6. We keep our variable, we keep our exponent. Now what about example F? With example F, we have 3x squared plus 4x cubed. And so the question comes down to, are these like terms? And the answer is no. One of them is a square, one of them is a cube. They are not the same. And so this one cannot be simplified. And we're done. You do not add the exponents. We will talk about when we do that in a later chapter. For now, all we know is that we cannot combine these two things. Now let's get into some other problems where we have more than two terms. If we look at example G, the first thing we want to do is identify like terms. Here we have 7x and 3x are like terms. They both are x terms. So we can combine them, and we get 7 plus 3 is 10. Keep the x. We also have constant terms. Our constant terms can always be combined. If not, then everything we've done so far is kind of pointless. So we can combine 5 and 8, and that gives us plus 13. And so our final answer is 10x plus 13. We cannot combine this any further because one of the terms has an x and the other one does not. They are not like terms. Let's look at example H. Example H, we have, first for our like terms, we have 4x can combine with 2x. That would give us 6x. We also have 7y can combine with 3y, giving us 10y. We leave our answer like this because x's and y's are not like variables. They are not the same variables, and therefore we cannot combine them since they are not like terms. So there are some basic ones that you can look at. So far, we haven't talked about dealing with negatives. We talked about some subtraction, but we haven't seen anywhere we have negative numbers in our answer. So let's go ahead and look at this section. When dealing with signed numbers, we want to use the same procedure. We want to combine the numbers as we did in the previous material. We keep the variables. One thing to remember is the coefficient includes the sign that is in front of it. So for example, the expression 9x minus 4y minus 5 has three terms in it. It has the 9x, it has negative 4y, and it has a negative 5. So let's go ahead and look at some examples. If we look at example A, we have 7y plus negative 12z plus negative 9y plus 15z. So again, I want to identify my like terms. We have y's and z's here. So I'm going to combine my 7y and my negative 9y. If we combine 7 and negative 9, note that they have different signs, so we are going to subtract and keep the sign of the larger number. So we get negative 2, and we keep the y. For our z terms, we have negative 12z and 15z. Again, we have different signs, so I want to subtract and keep the sign of the larger number, which in this case is the 15. So we get 3, and I keep the z. We cannot combine anything else since y and z are different variables. They are not like terms. They cannot be combined. All right, let's look at example B. Example B, we have 8a minus 9a. So I want to subtract. We have different signs. And so we get 8 minus 9 is -1. Remember, we subtract, keep the sign of the larger number, and we keep the variable. Now, remember in the previous slide, we saw that we aren't really used to, or mathematicians are very lazy and they don't necessarily always like writing the 1. So you can write this as -1a or just minus a. Either one of these answers would be considered correct. Okay, let's look at example C. Example C, we have, starting on the left, we have a 2. Does it have anything that it can combine with? No, there are no other constant terms, so we're just going to keep it. For our 3x, we can combine 3x and -8x. 3 and -8 have different signs, so we are going to subtract to give us 5. Our larger number is negative, and so it will be -5, and we keep the variable. So we get 2 minus 5x. For our last example, we have -4x minus 9y minus 2x plus 12y. So starting with -4x, does it have anything it can combine with? It can combine with -2x. These numbers have same signs, so we're going to add the numbers and get 6. We keep the negative. We keep the x. For -9y, I can combine that with 12y. Since these have different signs, we want to subtract and keep the sign of the larger number, so we get 3, and we keep the y. So that takes care of some examples for simplifying or combining like terms when we have some negatives in our problem. Now, go ahead and try the following problems on your own. Bring them to class as well as any questions that you may have.